Okay guys, let's recap what we did in the previous lesson. Remember, at two turning points, there's an extremely important principle. Okay, this has got to be seriously easy. Now, you've got to listen to me. Man, do you know, Mzansi, you can get, I'm telling you now, you can do well on calculus. It is such a nice section of the syllabus. Now watch here. People always get stuck with this. When you've got a turning point, the gradient is 0 there. But there's a point on there. Now look at this again. At the f of 2 is the y value. Okay. The f prime of 2 is the gradient of the tangent, which is 0. At the turning point, the gradient is 0, but the y value, the f of 5, is 18. Now this is going to lead you into the first part of this question. Okay, so stay with me. It's quite exciting. Here we go. Show that a, b, and c is equal to those values. Okay, remember, they gave us an original equation, negative 2x cubed plus ax squared bx, and then the c. Okay, now we've got to show that. Now watch this. There is our equation. Now how do we do this? Well, what do we know? Go back and check the graph. We've got turning points, and there's a lot of information that we can use regarding turning points. So how do we do this? Well, firstly, t 2 minus 9 is actually a turning point. Now, what do we know? F of the x, f of 2, and f prime 2, the derivative. Okay, so there's two important things here. Okay, go back and look at the picture. It's a minimum turning point there. And so if we look at this, how are we going to do this? Very simply put, let's go back and check. There's the turning point, 2, negative 9. And what do we know? Also, the gradient is 0. So let's see what we can extract from this. The derivative, now focusing on gradient being 0, the derivative, look at this, minus 6x squared plus 2ax plus b, and that c goes missing. Now you've got the gradient, but we specifically at a turning point. So what do? Look at this, check this out. We know that our x value is 2. So if we change all the x's to 2, and very, very specifically, what do we know at a turning point? The gradient is 0. The derivative at 2 is 0. So the derivative is at 2 is 0. So 0 and equals this. So we now get an equation here. And if we tidy it up, let's just look at that again. Minus 6 times 2 squared plus 2a times 2 plus b. And that all equals 0. Remember the gradients. This is so important, people. The derivative at 2 is 0. This guy is 0. But the x value is 2, so we plug in 2 into that there. And that's a very powerful principle there. Okay, so let's tidy this equation up. And what do we know? Okay, we've got that, so it gives us negative 24 plus 4a plus b. Now, that's great. Let's leave it at that. But what else do we know now? We can say 24 is equal to 4a plus b, which is cool. And then we also have another turning point. But what was that? That was the maximum one. There's a turning point. It's 5 and 18. What do we know about the derivative at 5? It's 0. So let's see. If we take that, we got the derivative there, so we plug in 5, all the x's change to 5, and the gradient at 5 is 0. There's a tangent line, it's horizontal, the gradient is 0. At a turning point, the derivative at that point, in this case 5, is going to be 0. Okay, let's tidy up this equation. Okay, so if we look at this, we've got that one and we fix it up. Now what do? Well, we've got that equation and the previous one, 24 is 4a plus b. Those are the two things. We used the two turning points, we got the derivatives, we plugged in the x values, and we put them equal to 0. So what do we now have? Guess, you guessed it. Somebody said it out there. Simultaneous equations. Oh, my. I love this. Okay, now how do we solve simultaneously? No problem, check this out. Well, if I simply merely subtract these. Okay, 154 minus 24 gives you 126. 10 minus 4 is 6, and the b's conveniently disappear. Good. And then if you divide, 126 divided by 6 is 21. That's what they wanted us to show. A is 21. So great. How do we get B? Well, pick any of the equations that you like. Let's take the easier one. We know that A is 21. What's 4 times 21 is 84. So B, of course, is minus 60. What a pleasure. Wat a plezier. Okay, I love this. This is such good stuff, man. It really makes me want to sing and scream. Okay, wow. It's so lekker. Now let's go on and see. Now we've got A and B. So what we can do now is we can plug in the A and the B, which we conveniently did there. Now the problem is the C. This is nasty. We've used the turning points. We've used the fact that the derivative equals naught. We're very excited about this, but how do we get C now? Watch this. This is beautiful. I'm going to pick a point. You can use anything. It's a point on F. Okay, it's a point on F. So what do we do with that point? Here comes the magic. Stay with us on Matrics Uploaded, and let's see what we're going to do with this in the next lesson. It is extremely exciting. Don't go away. Stay with us. The magic is about to begin on Matrics Uploaded. Hallelujah. Stay with us.